Welcome to a new exercise. Following what we learned with the examples about trains, this time we have two objects accelerating due to the action of gravity, and we're going to study their motion as they fall down from the edge of a building. So let's have a look. A person drops a red ball from the edge of a building 37 meters tall. 1 second later, the person drops a green ball. Find the distance between the balls 1 second after the green ball is dropped. Determine how far from the ground the green ball is when the red ball hits the ground. As usual, we start drawing our cartoon with our coordinates, our y-axis. We draw the ground, so this is y equals 0. We also draw the edge of the building, and there will be two objects falling in this case. A red ball will be dropped, and when this ball has been going down for 1 second, a second ball will be dropped. This means 1 second later, this green ball will start moving. So when this ball is here, the red ball will be somewhere down here. So the important part is that there is a time delay of 1 second between the two objects. The first question is find the distance between the green and the red ball 1 second after the green ball has been dropped. So we want to find the distance between these two objects, and we can call this separation delta y, because y is the axis that we're using, and we can identify then the coordinate of the green ball, and then we can identify the coordinate of the red ball, and then just take the difference, and this will be the separation between the two. So let's start with that. For the red ball, we have that the coordinate is y0 plus vy0 times the time minus 1/2 gt squared. The initial velocity is 0 because the two balls in fact are dropped, and the initial coordinate is the height of the building. So we know this value. This is h. This case is 37 meters. So this number we have minus 1/2 gt squared. This equation here represents the coordinate y of the red ball at any time t. We can repeat the same procedure for the other ball. Y is y0 plus vy0 t minus 1/2 gt squared. Once again, this ball was dropped, so this term is 0, and the initial height was h minus 1/2 gt squared. Now the two expressions have exactly the same form, they have exactly the same terms, but one thing that is different between the two is the value of t, because the t here on the right refers to the time that the green ball has been moving, whereas the t here on the left is the time that the red ball has been moving. The question is, find the distance between the balls 1 second after the green ball is dropped. In other words, this t here is 1 second. So the green ball has been moving for 1 second. That means that the red ball has been moving for 2 seconds, because the red ball started moving 1 second before. So this t is 2 seconds. And we can plug these numbers. So we have h, which is 37 meters, minus 0.5 times 9.8 meters per second square, times 2 second square. And this is 37 minus 0.5 times 9.8 times 2 squared. 17.4. You can simply write 17 meters. So this is the coordinate of the red ball 1 second after the green ball was dropped. We can now go to the other side and do the same. H is 37 meters minus 0.5 times 9.8 meters per second squared times 1 second squared. 37 minus 0.5 times 9.8 times 1 square, well, it's just 1. This is 32 meters. 32 meters. Now that we have the coordinates of the green ball and the red ball at the time that we're interested in, that is 1 second after the green ball was dropped, or which is the same, 2 seconds after the red ball was dropped, we can determine the separation between the two. We can write delta y to be y of the green ball minus y of the red ball, which gives 32 meters minus 17 meters. And this is 15 meters. So this is the separation between the two balls. There are 15 meters between the red ball and the green ball, 1 second after the green ball was dropped, or 2 seconds after the red ball was dropped. Excellent. Let's look at the next question. Determine how far from the ground the green ball is when the red ball hits the ground. Here we can return to this formula that we obtained before we evaluated at t equal 1 second. This formula is valid at any time. So it would be great if you could know for how long the green ball has been moving when the red ball hits the ground. But we can do that because we derived in a previous exercise a formula that tells us the time that it takes for an object to fall from a given height. I will write this here. That time was square root of 2h divided by g. So if you don't remember this formula, I highly recommend that you have a look at that previous exercise, because now we can simply plug these numbers. We get 2 times 37 meters, because this is the height of the building, divided by 9.8 meters per second square. Square root of 2 times 37 divided by 9.8 is 2.7. 2.7 seconds, because this is the unit of time we're using here. So this is the time that it takes for the red ball to go all the way from the top of the building to hit the ground. Now, it is tempting to just take this time and plug it in the formula here on the right for the green ball, but we need to remember that the green ball was dropped 1 second after the red ball. That means that when the 2.7 seconds happen, that means the point in time when the red ball hits the ground, the green ball has been traveling for 1 second less than that. That means, if I rewrite this formula here, y is h minus 1/2 g t squared. Again, this formula is valid for any time, but we're interested in where the green ball is 2.7 seconds after the red ball was dropped, which is when the red ball hits the ground. But the time that we have to plug here is not the time 2.7 seconds, because t in this formula refers to the time that the green ball has been moving. So if the red ball has been moving for 2.7 seconds, and we know that the red ball was dropped 1 second before the green ball, that means that the time that we have to put here is 2.7 seconds minus 1 second. In other words, 1.7 seconds. Okay, so let me repeat that. This is the time that the green ball has been moving when the red ball hits the ground. So then we can plug this time here. We get 37 meters minus 0.5 times 9.8 meters per second square times the time the green ball has been traveling at this point, which is 1.7 seconds. And this t has to be squared. 37 minus 0.5 times 9.8 times 1.7 squared. 22.8, 23 meters. So this is the coordinate of the green ball when the red ball hits the ground. So now we can answer the question. Determine how far from the ground the green ball is. Well, here's the answer. It's 23 meters. The green ball will be 23 meters from the ground when the red ball hits the ground. In the next exercise, we continue dropping things out of buildings, and in that case we're going to be interested in time, and just as before we're going to encounter this quadratic equation, so make sure that you check that.